The last method of determining the outcome of an election in our textbook at least is called the method of pairwise comparisons. And now I wanted to actually also mention that these are not all of the methods that exist for determining the outcome of an election. They're just the ones that our book goes into. They're kind of the most common, most sensible, most conceptually, valid methods that exist, but there are other methods too. And ultimately, all of these methods are invented by humans, and you could invent your own method for determining who's going to win. But obviously, it should be rooted in some sort of sense, and like there should be a reasoning that we're following this method. And I hope you can see the idea, kind of the ideology behind each of these methods and why they're sensible. But let's get into this method specifically. And the general idea of this method of pairwise comparisons is to pair up each candidate and compare them on a head-to-head, one-on-one basis. And it's sometimes called a head-to-head method or Copeland's method. And it works very much like a round robin. Now, what a round robin is a common term in like games, like gaming, trying to determine. It's a method of trying, like a tournament setting, trying to figure out who is the best person here. Like say for example, bridge or whatever. We're trying to figure out who's the best bridge team, or you could have a round robin, which just means that every team is going to play every other team, and we can see who's the best by figuring out, well, who beats the most other teams. It's a little bit different than a bracket. A bracket, like in basketball, would be where each team plays head to head and is then eliminated, and then they play the next team that survives, and so on. Which is not that's not the same as a round robin because they're being eliminated as they go. With round robin, every team would play every other team. So like if you imagine a tournament with 64 basketball teams, each team would have to play 63 games because they all have to play each other, and it's just a lot more extensive. And with voting, it can often be a lot harder to actually do a complete head-to-head comparison matchup. But anyways, how does this actually work? Basically, each candidate is paired up directly one at a time, and we want to determine between each pair who is the winner. Who would be, like imagine them going back to the class presidency example. We have Art, Ben, Kathy, Debbie, who want to become class president. We could imagine, well, Art and Ben, if we just line them up next to each other and have everyone vote, who's going to win that? And we could do the same thing for Art and Kathy, and so on, and try to figure all of that out. And we can actually use a preference schedule to determine that, and that's exactly what we're going to look at as we get into this example. But basically, we then look at each column of the preference schedule to see how many voters prefer Art to Ben, add up how many voters prefer Art, and how many voters prefer Ben. So basically, we look at, say, one pairing, see who is more highly preferred in each column, and then basically tally them all up. Whichever candidate is more highly preferred gets 1 point in the method of pairwise comparisons, while the loser gets 0 points. In a tie, each player gets half of a point. And when we do the example, we'll talk about the point system and how we figure out the outcome. And it also says to make sure to calculate the head-to-head matchups for each pair of candidates. And then the final ranking is determined by the above point system. So let's just jump into an example, because I think in this method it's easier to sort of see it in action. But hopefully that step-by-step process from the slides makes some sense. But let's just get right into it. And also, first of all, when you're starting the method of pairwise comparisons, what I'd recommend doing is make sure to find all the matchups first before we actually start doing any math. So in the class presidency example, sorry, I'm very tired because I'm doing this way too late due to the reasons you probably read in my announcement. But sorry if I slur or something. Just it's because I'm pretty tired. But anyways, basically we want to pair up each candidate. So how I like to do is start with, well, I have Art. I could play Art against, Art's going to need to face Ben. Art's going to need to face Kathy. So what I'm writing is like Art versus Ben, Art versus Kathy, Art versus Debbie, just as a way of keeping notes and keeping track of each of the matchups in the head-to-head methods. And then I could then move on to Ben and say, well, Ben needs to play everybody. Now, I don't need to do Ben versus Art again because Ben has already played Art, right? You don't need to do the order doesn't really matter here because it's all going to give you the same answer. So you can skip the duplicates And then I could say, well, Ben needs to play Kathy. Let me give myself a little bit more room here. Ben is going to need to play Debbie. And then move to Kathy. Kathy has already played Art. She's already played Ben, so she will need to play Debbie. And that actually is it because Debbie has now played everyone else. But basically, there's 4 candidates. Each one is going to need to play 3 times. So D has 3 matchups, C has 3, and so on. And there's actually a mathematical way of doing this. If you take the number of candidates, which is 4, and subtract 1 from that, we're going to start with 3. And that's kind of like, notice how when I started with Art, there's 3 potential matchups. Then when I move on to Ben, since one of them's already been used, it's going to go down to 2. And then for the third candidate, it's going to go down to only 1 new matchup. But basically, if you start with n minus 1, where n is the number of candidates, and just add consecutively smaller integers to that, add them all up, that will give you the number of matchups. So what I can tell is that I have 6 matchups here. So like say for example we had 10 candidates, or like 8 in the example of the Cy Young. If we start with 7 plus 6 plus 5, basically this, if we do this sort of math, this will tell us exactly how many matchups we're going to have. And we're not going to do the Cy Young example for the pairwise comparison because we'd have to do 28 of these things and it would take forever. But it'll give us a sense of, you know, how hard of a problem is this. Anyways, now what we still need to do is figure out, well, who's going to win each matchup and how do we actually do that? That's, you know, another important facet of these problems. But basically what it's done is we look at each column and figure out how many voters prefer A to prefer B. And what I like to do is circle each pair. Like if I'm looking at A versus B, in the first column, those 14 voters clearly prefer Art to Ben because Art was their first place choice and Ben was their second. So if we're examining them, basically I'm ignoring C and D and just looking at who is higher between A and B. And in the next column, I'm going to do the same thing. Well, Ben is higher than A. Those 10 voters prefer B to A. Same with the third column. Those 8 voters prefer B to A. And actually, in all of the remaining columns, they're all going to prefer B to A. Because in those columns, A was last. So A is never going to win a head-to-head matchup where they're last because, you know, clearly these people prefer everyone else to A. And when A is first, they're going to win every single one of those matchups. So then also the number of points is not based on number of columns, but it's based on number of voters. So in this case, 14 voters preferred A to B, and the rest of them preferred B to A. So that's 10, 18, 22, 23. And that's how we determine who's going to win the method of pairwise comparisons. Well, that's not it. That's just in that specific matchup, Ben is going to defeat Art. Ben is more highly preferred to Art. And again, this makes sense because we're examining each voter's preference on a ranking system, and we can see that Ben is preferred overall. And then we're gonna repeat that process for every other pair and see, well, who comes out on top. So let's go ahead and do that. And actually, I'm going to erase the circles because those make it harder to, you know, check my other matchups. But actually, when it comes down to Art versus Kathy and Art versus Debbie, they're all going to be the same as well because Art is preferred to both Kathy and Debbie here, but both Kathy and Debbie are preferred to Art in every other column. So those actually are going to coincidentally turn out exactly the same, which is not typical in most preference schedules, but actually Art is not going to win any of those because they were last so many times. So this really punishes a lot of last place votes and it rewards a lot of first place votes, which is another sensible procedure. As you know, we kind of discussed when we were first getting into, you know, who should probably win and who should probably not win. But then let's examine the rest of them, Ben versus Kathy. And so what I like to do when I'm doing this is just start by circling whoever comes out on top in each column. Then add up how many circles each person has. So Ben has 18 there, and Kathy has 19. So Kathy is going to ever so slightly win the head-to-head matchup with Ben. That one's very, very close. You could argue that there's not really a big difference between them, but she does come out on top slightly. And if there were a tie, in this case it's impossible because there's an odd number of voters and you can't split them in an even way. But if there is a tie, that would be just a tie and they would each get half of a point instead of a win. It's just like a normal tournament system where basically Ben gets a win here, but Ben has a loss. So you could kind of think of it as, well, what's their record in this matchup? He has one win, one loss, and then whoever has the most wins is gonna win the method of pairwise comparisons at the very end. But let's finish up, then we can check that. So between Ben and Debbie, um, it looks like Ben comes out on top way more. And actually, since Ben won those first two columns, that's already a majority. And also another thing is, once you get to a majority, that's just done, because if you have a majority, you're going to win. Period. And every single candidate is going to get a majority in their wins, of course. But that would be 29 for Ben and 9 for Debbie. That's the most clear cut of the head-to-head comparisons here. Ben is way higher than Debbie. And then between Kathy and Debbie, again, I'll just go ahead and circle. And this is why I recommend you use pencil, when you're doing math, is that way, you can take notes like this and erase them, no big deal. But if I was trying to do all of that math without erasing them each time or without, undoing it, it would have been really hard to keep track with so many circles flying around. But anyways, Kathy's also a clear winner here, right? This would be 25 to 12. And now we are done with all of the math. Well, last but not least, we need to count up, well, how many wins does each person have to do the final ranking? So in this case, notice that actually Kathy defeated everybody. Kathy was more highly preferred than Art, Ben, and Debbie. So we'd say that Kathy is 3 wins, or you could say she's 3-0. But Kathy, 3 wins, and she's going to win the method of pairwise comparison. Now, Ben had 2 wins. Ben defeated Art and Debbie. Debbie had 1 win against Art, and then Art had 0 wins. So if you wanted to rank, I guess wins is plural. 0 is plural, right? Which is kind of weird, but yeah, English. That's why I teach math. Bad joke. Occasionally I'll try to make jokes. Probably not funny, especially this late at night. I don't even know if that was a joke. Whatever. I'm tired. Let's wrap this video up. Okay, so Kathy wins. She was actually undefeated, and actually this is one of the terms that was in the slides that I forgot to mention earlier, is that if a candidate is undefeated in the head-to-head matchup, we refer to them as a Condorcet candidate. It's a French word, which is why it's not Condorcet or whatever. It's Condorcet. And that's just means they were undefeated. And why do we care? Well, if they're undefeated, that's a strong indication for a candidate to be elected, right? Kathy would be a pretty good choice here because on a head-to-head basis, she beat everybody. And this is basically, in general, people prefer Kathy to everyone else. It's an excellent way of determining, who's the best. Whereas Ben beat 2 out of 3, pretty good still, but not undefeated. Debbie only had 1 win, and Art could not beat anyone. So it gives us a ranking on wellness for a set of candidates. And actually, in the next video, I'll do another example because this is a little bit of a tricky method as well. But I wanted to sort of do a compare and contrast. Now that we've gone through each method in the book and figured out the outcome, I wanted to compare what are the different outcomes that we had. And if you've kind of been paying close attention, you probably noticed that we're getting different winners between each method. So based on the pairwise comparison method, what we've determined is that Kathy should win. Kathy's a good choice. She's our elected class president. But when we use the plurality with elimination method, Debbie won with 23 votes because all the other candidates were eliminated, and Debbie ended up getting a lot of those votes in that particular order. When we did it with the board account method, Ben was the winner, ever so slightly over Kathy, with 106 to 104. And then when we did the initial method, the plurality method, Art won. So actually, notice that every candidate won under a different method. And why this is kind of disturbing or might be a little bit concerning of a comparison is that this was all done with the same data, right? These were the same numbers across the board. And imagine that we had an actual class election and we're trying to figure out the outcome. Well, notice each candidate won under a different system, and each one has a legitimate chance of being elected. So you could make a case for that literally any one of these candidates is a good choice. So it all comes down to, well, which of these methods is really the right method, which is the best, and how do I determine the outcome of an election? And that's exactly what Dr. Kenneth Arrow uh, tried to um, figure out in the early 1900s. Um, and he won a lot of awards for his work, and we're going to get into that in the next section. But basically, this is an important point: is that when we're doing election, it's not all about the data. It's also about what mathematical method are we using, and being aware of the way that the election works is really important, because if we don't really understand it, we don't necessarily know how our vote's going to count. And a lot of the time we should just vote sincerely. We should just vote for our favorite candidate. That way, we have a better chance of getting the data. But a lot of times people will vote insincerely because they want to, they know how the system works, just like in the in the United States. If you know the candidate's not going to win, why would you throw away your vote on a third party candidate? And a lot of that sort of behavior comes from trying to beat the system in a way and not really voting truly sincerely. If everyone voted sincerely, the outcome could be different too, and other parties other than just the two main parties could actually win. But it's kind of the thing about, you know, most people are not educated enough to know that, and it's sort of like fighting an unwinnable war or an uphill battle. But anyways, uh, in the next video, we'll do another example, and then we'll circle back to this idea of, okay, what method is the best? How do we know which to do if we're going to have our own election in, our life or whatever?